Hello everybody, welcome to page 47. Today we only got a couple examples, 3 examples. What's making this a little bit different today is that you're going to see that we're still solving trig equations like we did in the past couple lessons, but now they're mixing and matching it. Instead of it being all sine or all cosine or all tangent in the equations, there's a mix and match of things. So I need to manipulate them to get them to be the identities I need them to be. So some really important ones that you want to be thinking about as we're doing this, right? As we're working on this. Hold on, my pen wasn't on. There we go. So as we're working through this, if you see functions being squared, we want to be thinking about our Pythagorean identities. So we know that our Pythagorean identities were that sine squared plus cosine squared equals 1. We know that the other one is that 1 plus cotangent squared equals cosecant squared. I remember that 1 and tangent go together. And the last one is 1 plus tangent squared equals secant squared. So knowing those 3 identities is really important because then you know you can change sine into cosine or vice versa. You can change cotangent into cosecant. You can change tangent into secant. Knowing those is really helpful in working through these problems. So let's go ahead and dive right into this first one and see what happens. So you can see here we've got cosine of x minus 1 equals sine squared of x. So immediately what pops up to me is I'm working with cosine and sine, and I know this identity right here can help me manipulate sine into cosine. Specifically, what I know is if I were to rewrite that one up top, if I were to move the cosine squared to the other side to leave sine squared by itself, we would get 1 minus cosine squared. So what I know is that I can replace the sine squared with 1 minus cosine squared, and that's what I'm going to do. Cosine of x minus 1 equals 1 minus cosine squared of x. And so what I'm going to do is I'm going to move all my stuff around. So I'm going to subtract this 1 here and subtract 1 here. I'm going to need to add cosine squared to the other side, which there is nothing to add it to, so it's just going to kind of take its own place. But you can see that now that cancels, what's left is we have cosine squared of x, my plus cosine of x that was originally there, and now minus 1 and minus 1 makes negative 2, and I've got 0 left on that right side. And now I can actually go ahead and move into factoring and solving this like we were doing on the last page of notes. So in this case, I need 2 numbers that would multiply to make negative 2, but it would add up to make that positive 1 in the middle. So I know it's going to be positive 2 and negative 1. And let's factor that out. So cosine plus, hold on, put my variable there. Cosine of x plus 2 and cosine of x minus 1 equals 0. And so when I set up these 2 equations, cosine x plus 2 has to equal 0 and cosine of x minus 1 equals 0. And we just got to solve these 2 things, which are both pretty easy. Here I subtract 2, so I get cosine of x equals negative 2. Here I add 1, so I get cosine of x equals 1. Well, this first one right here, I know that this negative 2 is not between negative 1 and 1, which is what cosine has to be between. So because it's outside of that range, I immediately can rule this one out and just say, does not exist. There's no way to make cosine x ever equal negative 2. Now, the other one, when does cosine equal positive 1? Well, since cosine, again, is the x term, right? We know cosine is the x value. That's going to happen at the up and down, the y-axis on our unit circle. Specifically, positive 1 is going to happen at the top of the y-axis. So when x equals pi over 2. Now, making note here that this said negative infinity to infinity. So we're not stopping here like we did on the last page of notes. We're going back to like 2 pages of notes before on page 45, where since it's going to infinity, we have to include the infinite set of answers. So we're going to put x equals pi over 2 plus or minus, and with sine and cosine, we put plus or minus 2 pi, and I'm going to put a k here. Those will be our answers. All right, taking a look at this next one, it says solve this on the interval applying our identity. So I've got 3 tangent of alpha minus 2 square roots of 3 sine of alpha is equal to 0. So again, this situation where we really got to work on seeing what we could do to manipulate this to make it work in our favor. This one doesn't really work with the Pythagorean identity, right? We've got tangent, we've got sine. Tangent and sine don't have the same identity. If you go back up here to our Pythagorean identities, sine can be manipulated into cosine, and tangent can be manipulated into secant. So this isn't really going to help us because we've got tangent and sine. what we have to think about then is, well, how could I write tangent that would include a sine? And the only way that comes up is that I could rewrite them using our quotient identity. So 3, and instead of putting, let me not put that parenthesis, that might get confusing. Instead of putting tangent, we'll put sine of alpha over cosine of alpha minus 2 square roots of 3 sine of alpha equals 0. Well, now they both have a sign in them, right? So thinking about the factoring rules that we've been learning, we could then take a sign out. And you can only do that with the number on top, right? You can't ever do that with the number on the bottom. So if it had been cosine, that wouldn't work. But when it's the number on top of the numerator, you are allowed to factor that number out. And that's what we're going to do. So I'm going to factor a sine of alpha in front, which means left here I've got 3, 1 over cosine of alpha minus 2 square roots of 3 equal to 0. And now there is a small modification we can make on the inside right here. 1 over cosine of alpha, since we've taken the sign out, we know that this would represent the same thing as its reciprocal function, which is secant of alpha. So I think that that's going to help us a little bit, getting it out of its fraction form and just leaving it in its simpler form. And now we don't quite have them exactly the same function, but at this point we've now at least separated them. And again, noting that there's multiplication going on here, we know that either this equals 0 or this equals 0. One of those things equals 0, but I can solve them now because I've separated them. So the first one, already kind of done for us, right? Sine of alpha equals 0. So when does sine give us 0? Well, since sine is the y value, I know that's going to be on the y-axis, and there's 2 spots. Alpha could be pi over 2, and alpha could also be at the bottom of the y-axis at 3 pi over 2. Now, take a look up here. This one says to go from pi to 2 pi. So there isn't an infinite set of answers. It's only pi to 2 pi. So that tells me that I'm actually really only looking at quadrant 3 and quadrant 4. So this answer is irrelevant. We don't need that one because that one's in the top. That's in the between quadrant 1 and quadrant 2. This answer is specifically in between our quadrant 3 and quadrant 4. So that's going to be the only answer we actually need to pull from that one. Now with the other one, we got this 3 secant of alpha minus 2 squared roots of 3. 3 secant alpha minus 2 squared roots of 3. Set that equal to 0. So this one's going to look a little bit ugly at first, but we're going to add 2 squared roots of 3 to both sides. Cancels out here. And I get 3 secant of alpha equals 2 square roots of 3, positive 2 square roots of 3. And then we will take this and we're going to divide this side by 3 and divide this side by 3. That cancels here. And I get secant of alpha equals positive 2 square roots of 3 over 3. So what I know is I can't really work with that as a secant, right? Because we don't have the unit circle for secant memorized, but I can bring it over here and switch it. I can switch it to cosine of alpha, and if I do that, what's going to happen is I have to take the reciprocal, right? Since secant and cosine are reciprocals, I'm going to need to flip that upside down. So it's going to become 3 over 2 square roots of 3. And we know that we can't have square roots in the denominator, so let's multiply that. We'll multiply by that square root of 3 in that denominator. That was ugly on top. Let's try that again. There we go. So we're going to multiply that together and see what we end up getting. So on the top, we get 3 square roots of 3. And on the bottom, square root of 3 times square root of 3 is 3, and 3 times 2 is 6. So now what we have is this 3 and this 6 that could definitely simplify. So the square root of 3 on top, we divide that 3 by 3 and we get 1, divide 6 by 3 and get 2. So what we find is that the cosine of alpha equals the square root of 3 over 2. And that is on our unit circle. So we know that cosine being the x value is going to be positive in 1 and 4. But again, we've eliminated quadrant 1 and 2. We're only looking at 3 and 4. So really the only answer we need is to figure out where cosine would equal square root of 3 over 2 in quadrant 4. So I know it's when the denominator is 6. And in quadrant 4, the denominator is always going to be, the numerator is always going to be 1 less than 2 times the denominator. So 2 times 6 is 12, minus 1 is 11. So this will be 11 pi over 6. And that'll be the only answer we got to get for this one. All right, and in example 3, this time we've got one that's looking at the unit circle from 0 to 2 pi, so we don't have to eliminate anything. Taking a look here again, we've got a lot of weird things going on, right? We got secant x minus tangent x. Now, with this one, let's think for a second. How are we going to make this one work? I didn't look at it ahead of time. I do know that they both are Pythagorean identities, right? They're connected together up here. They're connected through tangent squared and secant squared. So I do know that they're connected up here through a Pythagorean identity. And there is a way to make them both squared. I think we can try that. Let's try that. Let's square them both. So here's the easy way to square them both, right? We know the difference of two squares, right? That's a very important concept in math, and especially in these trig functions, is that if you have something like x squared minus 16, that factors into x plus 4 and x minus 4, right? So I know that this could become a difference of two squares if I were to multiply them together. This might be one where we try something and see if it works and then backtrack and see what happens. That is okay. Like I've said before, sometimes these problems do some weird things to you. I actually don't like what I talked about over here. Let's get rid of this. Important idea, but not what I think we need for this one. I think what's going to be useful for this one is that we square both sides, right? If I take this side and square it, that's okay as long as I take this side and square it. So what's going to happen is on the left side, we end up with secant x minus tangent x multiplied by secant x minus tangent x. Remember, you can't just go, oh, I'm going to square both of them, put secant squared minus tangent squared. That doesn't work. You got to FOIL it together. On the right side, though, it's just 1 squared, and that's easy. 1 squared is 1, because it's still 1 times 1. And we're going to go ahead and FOIL this out. So secant times secant and secant times tangent. Over here, we're going to get secant squared and then minus secant x tangent x. And when I FOIL negative tangent secant times x and negative tangent times negative tangent, we're going to get negative secant x tangent x again. And this time we get plus tangent squared of x. And so when I bring these together, I've got secant squared of x minus secant tangent x. Sorry, minus 2 secant tangent x plus tangent squared of x. So I think I was on to something, and I'm realizing that's not going to work either, because we could change this tangent squared. So let's see where I was headed. I don't think this is going to work. Again, this is a very important lesson in this topic, right? Sometimes you're going to do things and it's not going to work, and that's okay. You can't let that be the reason you shut down and say, oh, I can't solve this, right? You have to keep persevering through it. So let's see where I was going and see why this isn't going to work, and why I'm realizing now, like, oh, I'm going to have to back up. This isn't going to do it for me. This isn't going to make it work. So if I were to change this tangent squared, right? We know that tangent squared is up here. If I move this 1 over, I could rewrite this as tangent squared equals secant squared minus 1, right? I could rewrite it like that, meaning I could take this tangent squared out and rewrite it as secant squared minus 1. So secant squared of x minus 2 secant x tangent x. And then rewrite this as plus secant squared of x minus 1 equals 0. I forgot the equals 0 up there, but we'll put it there. So while I'm getting closer, right, I've got a lot of secants going on here. Things are getting better. I can combine those first two secants together to make 2 secant squared. Bring this over here. So become 2 secant squared of x. That's the 2 secant squareds right here and right here. Minus 2 secant tangent. Oops, sorry. Minus 2 secant tangent. And then the minus 1 that we had left over. So it is getting a lot closer. I've got lots of secants in there, but still, there's this remaining tangent, and that's really throwing me through a loop here. That's really actually messing some stuff up. Oh, maybe it's not actually. Hold on. Hold on. Nope, I lied. It's still a mess. We're in a mess. So let's back up, right? Again, the lesson here, it's okay. It's okay that you get to these spots and say, I screwed up. It doesn't mean you're bad at this. It doesn't mean you can't do this. It means you are working through math problems. This is very normal. So I'm gonna start over here. So squaring both sides didn't work because it left us with too many things, right? So let's try something else. Let's think about something else. Now, I feel like I've kind of exhausted a lot of my options, so maybe we're going to try turning these into sine and cosines, right? So we know that secant of x can be rewritten as 1 over cosine of x minus tangent of x, which we know is sine of x over cosine x. Okay, so we've got that. Still equal to 1. I think I said it was equal to 0 earlier, which could have been a mess up that's causing me some issues, but it is equal to 1. So then, looking at this, what if then we started by combining these together, right? So we could put these together because they have the same denominator. So we could rewrite this as 1 minus sine of x over cosine of x equals 1. And ooh, I did mention this earlier. I talked about how difference of two squares are super important, right? So I see that I have 1 minus sine of x on here. Well, I could multiply the top by 1 plus sine of x, which would help us turn it into a cosine squared. But then I might end up with some messy stuff on the other side. I feel bad that I'm leading you through some mistakes, so I'm gonna have to edit this out. I will edit this part out of the video, and I will find the answer, and we'll pick up where we're supposed to go. But I got to think on this one a little bit to make sure I can figure out. And that's, again, okay. Don't be mad at yourself for doing it. C is going to be right after that, right? What I did is I squared both sides, and the problem is it made a mess, right? When I squared this side and squared this side, the problem I ended up with is I had too many, I had an extra tangents in there, right? It didn't separate the secants and the tangents, which is gonna kind of lead me to this, right? What I need to do is I need to separate the secant and the tangent from the get-go. So I'm gonna add tangent of x to this side and to this side. Let's get them separated right away. So now this becomes secant of x equals 1 plus tangent of x. Now I can go ahead and square both sides. And the reason this is going to help is now the left side is just secant squared of x, which we'll come to that in just a second. This right side becomes 1 plus tangent of x times 1 plus tangent of x. So when I FOIL that together, 1 times 1 is 1. 1 times tangent is tangent of x. Let me move over and do the tangent. Tangent times 1 and tangent times tangent. So tangent times 1 is another tangent x. And then here, tangent times tangent is tangent squared. And of course, we could do a little bit of manipulating there to move some stuff around and combine some like terms, right? So I'm going to bring the tangent squared first. We know that tangent x plus tangent x is plus 2 tangent of x. I'm going to move that positive 1 to the end so it's in the descending order. Well, now, because we've got that secant squared already isolated by itself, now we can apply our Pythagorean identity, right? Our Pythagorean identity up here said that secant squared is equal to 1 plus tangent squared. So when I come back down here, I can change that secant squared into 1 plus tangent squared now equals this mess over here. Plus 1. So now I can go ahead and solve this out. Subtract tangent squared. Subtract tangent squared. What's going to happen on both sides here? This cancels, and it cancels what's over here. And then subtract 1, subtract 1. This cancels, and this cancels. So I'm left with 0 equaling 2 tangent of x. In other words, we only care about when does tangent give us 0. When would tangent give us 0? Because, right, if you divide this 2 out, it doesn't really matter. 0 divided by 2 is still 0. So all we care about is tangent x equals 0. When does that happen? So since tangent of x being 0, since it's y over x, really it's when does the y give us 0, right? So that the x doesn't matter. That's only going to happen on the y, not the y-axis. It's only going to happen on the x-axis at the 2 poles of our x-axis. So x can be 0, x can be pi. Now take a look at the symbols. They used a bracket on 0 and a bracket on 2 pi, meaning they want us to include both the answers at 0 and 2 pi. Since 0 and 2 pi are technically the same, we're going to throw that answer in too. So technically it happens like when we start here at 0, when we go around here at pi, and when we go around here at 2 pi. So this answer right here comes up twice, once as a 0, once as a 2 pi. Now, had this been like a 0 with a bracket and a 2 pi with a parenthesis, then we wouldn't include the 2 pi as an answer. But since it's a bracket, we've got to include all of them. So we put all 3 answers, and that would be our solution. So again, just a lesson in not giving up. That definitely, you can look at the time up there. It took me a little bit of time to get that answer, and that is okay. Take your time. Think about it. Don't be stressed, because that's part of the process of these problems.